Dear students, today is the 10th February 2021. Fajans rules, polarization power, polarizability, covalent nature of ionic compounds. We are knowing the nature, the compounds which are to be formed by the three types of bonding. One is the covalent, which is sharing is there. Second, it is the ionic bond, and third it is the coordinate bond. So here the Fajan scientists who ruled out that the polarization power, polarizability and the rules for it. See here, while it is taught that the chemical bonds are divided broadly into ionic and the covalent type, however, in reality most of the bonds are neither purely ionic nor purely covalent. So these terms are used to indicate two extreme cases. The ionic bond refers to the complete transfer of electrons from one atom to the other, and whereas pure covalent bond involves equal sharing of electrons. Nevertheless, the nature of the chemical bonds in most of the compounds are somewhere in between above said, neither covalent pure, neither ionic. In general, it is expected that the ionic compounds are soluble in polar solvents like water and show high melting and the boiling points as well as exhibit electrical conductivity in the liquid state. As a rule, these compounds should be sparingly soluble in nonpolar solvents like benzene, carbon tetrachloride, etc. However, it is observed that few of the ionic compounds are easily fairly soluble in them and also exhibit somewhat less than anticipated melting points and the electrical conductivity in molten state. So, there are exceptional cases. So, likewise, that some chemical compounds they shows the exceptions with the pure ionic as, um, or pure covalent. It is also observed that some of the covalent compounds are soluble in water and exhibit electrical conductivity, though not very much in the molten state. So, this is also the reality. This clearly shows more or less covalent nature is also possible for the ionic compounds or vice versa. These observations can explain by the concept of polarization of anions and thus lead to the formation of Fajans rule or Fajans rules which help in deciding the nature of chemical bonds. So what is polarization? What is the polarization power of cations? What is polarizability of anion? What are Fajans rules for polarization? Applications of Fajans rules, examples. Fajans rules solved multiple choice question, etc. etc. So likewise this point is very important for the knowledge and for the skill purposes. So let us see what is the polarization. The negative charge on an isolated anion is evenly distributed around the nucleus. But the presence of a cation, the electron density is distorted towards it. Thus, the negative charge is unevenly distributed over the anion. One end of the anion gets the relative more negative charge than the other end, and this condition is referred to as polarization. The factors affecting polarization of an anion. Fajans rule were developed based on the concept the greater the polarization of the anion, the greater is the covalent nature. There are two factors which are crucial in deciding the extent of polarization as mentioned below. So first it is the polarizing power of cation. The ability of a cation to polarize the anion is referred to as polarizing power. It is directly proportional to the charge density, which in turn is directly related to the charge on cation, while inversely related to the size of an anion. Thus, the polarizing power increases with increase the size of cation. Smaller the cation are very effective in the polarization of anion. However, the polarizing power increases with increase in the charge on cation. So, this is very simple that the polarizing power is totally dependent on the charge on the cation. The polarizability of an anion. It is the tendency of an anion to undergo polarization. It indicates the easiness with which an anion undergoes distortion in presence of a cation. It is directly proportional to the size as well as the negative charge on an anion. The larger anions can undergo distortion very easily than the smaller ones. It is also important to note that the anions with greater negativity charge also undergo polarization easily. We can easily conclude that greater the polarizing power of cation and greater the polarizability of an anion, greater is the polarization and hence greater will be the covalence nature. This is based on the above discussion. Now, Fajans rules, which are they? Rule number 1, the smaller the cation or the smaller the anion, the greater is the covalent nature of the ionic compound. Rule number 2, the greater the charge on the either cation or anion, the greater is the covalent nature of an ionic compound. And third rule, the ionic compound containing cations with octet configuration have greater ionic nature, while those containing cations with pseudo octet configuration have appreciable covalent character. Now the consequences of the polarization. Let us see. Due to the polarization of anion and the increase in covalent nature, the ionic compounds exhibit abnormal behavior as mentioned below. Number 1, the solubility in nonpolar solvents. It is observed that ionic compounds with covalent nature are appreciably soluble in the nonpolar solvents with low dielectric constant. Second one, low melting points. The melting points of ionic compounds with covalent character are less than anticipated. And the stability, due to polarization, the anions may undergo easy oxidation when exposed to certain conditions, and the polyatomic oxyanions like carbonates, sulfate, etc. are distorted very easily in presence of cations with greater polarizing power and therefore are decomposed very easily upon heating. Now the applications of Fajans rule with example. See, it's quite easy. Covalent nature of alkali metal halides. We know that the size of cation increases from top to the bottom in the given group of periodic table. So in the periodic table we know the size it is going on increasing from top to the bottom as the atomic number increases. Therefore, the cation size of alkali metals also increases as shown. Lithium plus, which is of having plus 1 oxidation state, which is of less than the sodium plus, less than the potassium plus, less than the rubidium plus and less than the cesium plus. Therefore, the covalent nature of alkali metal halides containing the same halide ion decreases from lithium halide to the cesium halides according to the Fajans rule. For example, the decreasing order of covalent nature of alkali metal chlorides is lithium chloride is the less in nature. One should also note that the solubility of these compounds in non-polar solvents with low dielectric constant also decrease the same order, while the melting points follow the reverse order due to the decrease in the covalent character or increase the ionic nature. When the alkali metal ions is fixed while halide is charged and tend to the covalent nature depends on the size of anion. For example, LiF, which is the example, the order of covalent character of lithium halides with different halide ions is as shown below: lithium chloride, lithium chloride, lithium bromide and lithium iodide. In above case, the size of anion increases from chloride to iodide ion and hence the covalent nature which is increased from chloride to iodide. The stability of these compounds however decreases from lithium chloride to the lithium iodide due to increase in the polarization of anion. Indeed, lithium iodide becomes yellow when exposed to air due to oxidation of iodide to iodine, and it is due to strong polarizing and large iodide ion in presence of smaller lithium ion. Now the application number 2 with Fajans rule. Number 2, the covalent nature of chlorides of sodium, magnesium and aluminum is in the following order: that NaCl, which is less than the magnesium chloride than the aluminum trichloride. It is due to increase in the positive charge of the cation Na plus, which is less than magnesium 2 plus and which is less than aluminum 3 plus. Now the explanation: when the cations have octet configuration or inert gas configuration NS2NP6 in their outer shells, the effective nuclear charge properly shielded by the inner S and P electrons. Hence, their polarizing power is less than expected and therefore the ionic compound with these cations have less covalent character. Now, whereas the nuclear attraction is not properly shielded when there are electrons in the d subshell, and therefore the cations with pseudo-octet configuration NS2 and P6 and D10 possess high polarizing power, and therefore main group metal compounds are more ionic while the transition metal compounds are more covalent. In this case, for example, calcium chloride is more ionic due to the inner gas configuration 3s2 3p6 in the calcium 2 plus ion, and while the zinc dichloride is more covalent due to pseudo inert gas configuration in the Zn2 plus ion 3s2 3p6 3d10, and thus it is more covalent due to pseudo inert gas configuration. And now the last Fajans rule 3, the solved multiple choice question which is given here, that according to the Fajans rules the covalent nature of ionic compound is favored by large cation and small anion, large cation and the large anion, large cation and the large anion. So the probably and the we are knowing that by consulting with small cation and the small anion, small cation and the large anion, the answer is C, that is small cation and the large anion. Even though the crystal radii of both potassium and silver ion are almost the same, the melting point of AgCl is only 455 degrees centigrade, while that of KCl is 776 degrees centigrade. The best explanation is silver chloride has more ionic character than the KCl due to greater polarizing power of potassium ion. Second is KCl has more ionic character than the AgCl due to greater polarizing power of potassium ion. And third is AgCl has more covalent character than KCl due to greater polarizing power of silver ion. AgCl has more covalent character than KCl due to greater polarizing power of silver ion. And last one, it is KCl has more covalent character than AgCl due to greater polarizing power of silver ion. The answer is C, that silver chloride has more covalent character than the KCl due to greater polarizing power of silver ion. Explanation: the potassium ion has octet configuration of outer shell 3s2 3p6, therefore it has less polarizing power and hence KCl is more ionic, whereas silver ion there is a pseudo octet configuration 4s2 4p6 4d10 and its outer shell, therefore it has greater polarizing power due to ineffective shielding the nuclear charge by the d electrons. Students, please go through the this video, read it carefully. If you have any problem, please contact me and take care of yourself. It's very necessary. Thank you very much.